Hi everyone, and welcome. The topic for this video lesson is, make sure you like and comment so that I know this video was helpful. Also comment what topics we should cover next, and do me a favor, ring the subscribe bell. Thanks. Today we're talking about solving systems of equations, particularly the elimination method. And when we take a look at this, the most ideal format is when both equations are in standard form. As you can see on the screen, ax plus by equals c. When both equations are like this and the variables are completely lined up, it's most beneficial for us to use the elimination method. So let's take a look at our first example. We have negative 6x plus 5y equals 1, which is in standard form, and then 6x plus 4y equals negative 10, also in standard form. It's awesome that our variables are lined up, x and x, y and y, constant and constant. It's also very good that we have a match, so to speak, with our variables here. So the coefficients of the x terms, we have both a 6 and a negative 6, and that's exactly what we want. Like, this is the perfect setup for what we're trying to do. Since we have a matching pair and the signs are different, I'm going to go ahead and combine these two equations by adding them together. So negative 6 plus 6x will go away. 5y plus 4y gives us 9y. And then 1 and negative 10 will give us negative 9. And now we see that the variable x has been completely eliminated. That is the reason for the name, elimination. So to keep going, we'll divide both sides by 9 to get y alone. And now we know y is negative 1. At this point, we would just substitute the negative 1 into either of the equations that we choose. So we'll have 6x plus 4, and instead of y, we will substitute negative 1 equals negative 10. So now solving this equation that only has one variable, 6x, 4 times negative 1 is negative 4, equals negative 10. Solving for x still, we'd add 4 to both sides. We end up with 6x equals negative 6. Dividing both sides by 6 here, and x is negative 1 as well. And if we're highly skilled, we will write our answer as an ordered pair with the x value first, negative 1, and then the y value, negative 1. So that will be our solution. So for this problem, we have negative 7x minus 8y equals 9, and negative 4x plus 9y equals negative 22. The good thing is they both are already written in standard form, and the variables are aligned perfectly, which is good. Our only problem here is we don't have a matching set of coefficients. For example, the x terms, we have a negative 7 and a negative 4. Those won't eliminate. And we also have a negative 8 and a positive 9y. Those won't eliminate either. So we want to change those coefficients so that we have a matching pair, one number positive, one number negative, so that a variable will eliminate. Let's just go ahead and use the x. So we have a negative 7 and a negative 4. We need to think of a number that both 7 and 4 divide into evenly so that we can create a different number here. So 7 and 4 will both divide evenly into 28. So we need a positive 28x and a negative 28x. So let's just make the top one positive. We want this negative 7x to become a positive 28. So that means we need to multiply by negative 4. And we need to multiply the entire equation by this negative 4. Every term inside is multiplied. So negative 4 and negative 7 gives us positive 28x. That was the reason why we wanted to do that. Positive 28x, negative 4, negative 8y is positive 32y. And negative 4 times 9 is negative 36. Moving on, next equation, we want that to turn into a negative 28x. So we'll multiply the entire equation by positive 7. Once again, we multiply by everything on the inside. We get negative 28x plus 63y equals, I'm going to do a little scratch work, 22 times 7, 14. So that will give us a negative 154. So now we are all set for elimination. Standard form, variables aligned, and a positive and negative value that match. So we can go ahead and cancel here. Adding everything else, combining, we have 32 and 63, which gives us 95y. And negative 36 minus 154 is negative 190. Divide both sides by 95. And y comes out to be negative 2. At this point, we can take the negative 2, substitute it into either of the original equations of your choice. I'm going to substitute it into the first one. Just drawing a little separation here. Negative 7x minus 8, and instead of y, we substitute negative 2 in, equals 9. Keep working out, negative 7x. This will be positive 16 equals 9. Solving for x, subtract 16 on both sides. Negative 7x equals negative 7. Divide both sides by negative 7x is positive 1. Once again, highly skilled mathematicians, we would write this as an ordered pair. 1, negative 2 as our answer. So let's look at the next equation or next system of equations. We have 0.5x equals 0.25y, also equals 0.25y minus 0.5, also 0.2x plus 0.75y equals 6.6. A lot of things going on here. Number one, this system is not made up of two equations that are in standard form. So that's one thing we definitely are going to have to fix. Don't be tempted by the fact that it looks like the variables are lined up, because technically they are not. We want them in standard form and to be lined up, so we will fix that. Another thing is we have decimals here, and you may or may not like that. For me, I don't mind decimals and fractions, but I work problems out so much easier, more efficient, without less mistakes if I don't have them. So whenever those are given to me, I fix the problem so that I don't have to deal with them. So first, let's get everything all set up in standard form. Looking at the first equation, 0.5x equals 0.25y minus 0.5. We definitely want to move this over to the other side of the equation so that ax and by are together. So when we rewrite it, we'll have 0.5x. Moving something to the opposite side, we need to do the opposite sign. So negative 0.25y equals negative 0.5. So just checking, make sure we made no mistakes with our signs. We're okay. And the second equation is already good. 0.2x plus 0.75y equals 6.6. So now let's do a check off. Both in standard form, yes. Variables are lined up, yes. Now, we still have decimals and we still don't have a matching pair, you know, like a positive 0.5x and a negative 0.5x. So let's go ahead and get rid of the decimals, and then we'll worry about making sure we have the right number or making sure we have a matching number. So as I'm looking ahead at this problem, I see decimals with one decimal place, but then in the middle, the y coefficients have two decimal places. So to change everything to whole numbers, I'm going to multiply both of these equations by 100. Why am I doing that? Because there was 2 decimal places. 100 has 2 zeros. When I multiply by 100, those numbers will turn into whole numbers. The easy thing about multiplying by multiples of 10 is all we need to do is move the decimal that many places to the right. So 2 zeros is 2 decimals to the right. So this will become 50x. Here we get negative, move decimal 2 places to the right, 25y equals negative 50. Now you might think those numbers are pretty big, but there's no more decimals, and I think it's a lot less intimidating. So let's do the same thing to the bottom. 100 times 0.2 would be 20x plus 75y equals 660. Now look at that. No more decimals. Looks pretty good to me. So at this point, we want to set up one set of the variables so that they will eliminate. So we need to make the numbers match. We've been looking at x, so let's focus on y this time. We have a 25 and a 75. What we can do is turn the negative 25y into a negative 75y, and then they'll match. Just need to know what can we multiply that equation by so that the 25 will turn into a 75. Well, that's 3. So I'm going to multiply this entire equation by 3. And yes, our numbers are going to get bigger, but that's okay. Rewriting that equation down here, we have 150x minus 75y equals negative 150. So going through the checks, all in standard form, variables are lined up, coefficients that match, and they have different signs. So we are ready to add these equations together to combine them. We get 170x, the y's canceled, which was the purpose, and then 660 minus 150 gives us 510. Now we want to do 510 divided by 170, and that will give us 3. So x is 3. Now that we've completed that, what I like to do is go and substitute that back into one of the original equations. 0.5, not x, but 3 equals 0.25y minus 0.5. That's 0. Okay, so 0.5 times 3 will give us 1.5 equals 0.25y minus 0.5. So trying to solve for y, so we're going to add 0.5 to both sides. Cancels, we get 2 equals 0.25y. And we would divide both sides by 0.25. 2 divided by a quarter will give us 8. So we have x is 3, y is 8. Our ordered pair for our answer is 3, 8. And that is solving systems of equations using elimination.